Okay, so I'm going to get started here. So basically this week is going to be our first lab, which is the meters lab. And so what I thought I would do, first of all, is if you haven't already done so, you should definitely watch the videos from the previous week, from the first week. So in those videos, I kind of go over definitions of current, voltage, and resistance, and talk about circuits. And I went into a great deal of detail there. So basically, so that you can hit the ground running with the lab and with dealing with circuits. And so this is the first lab where measurements are actually going to be taken. Now, given the fact that this lab is going to be entirely online, unfortunately, I'm not going to have an opportunity to let you use the equipment. And so what I'm going to be doing this semester is I'm going to be doing the labs myself. I'm going to try to show you as much of that as possible, just so you can kind of get a sense as to how those measurements would go. I do have a standing offer, so of course you can use the data that I come up with and the data that I give you. You can do the full analysis without actually having to use the equipment yourself. Although sometimes I will expect you to know how to at least read some of the equipment, like reading some of the meters. I may ask you to read the meters that I actually show in photographs. So, try to give you a little bit of a sense. But anyway, the offer is if you happen to have the equipment or have access to the equipment yourself, please don't go out of your way to do this. Don't put yourself in any danger, breaking any shelter-in-place rules or anything like that to go get this equipment. But if you happen to have access to power supplies and resistors and meters, and later on we have oscilloscopes and things like that, if you happen to have access to the equipment, you are free to take your own data, in which case you are allowed to analyze your data instead of mine. The only thing I ask is that you let me know when you turn in the lab report that that's what you've done, so I can grade you accordingly. But anyway, so what I'm going to do with this first video for this week, since I've done all of the theory last week, this should actually not take too long. But anyway, what I'm going to do is I'm going to go over, at least for this first video, I'm going to sort of talk about the measurements that you actually would have taken if you were actually doing the lab. And then in the next video, I'm going to talk about what I actually expect you to do in terms of the analysis and in terms of reading the data that I actually give you. So I've got some short videos that I have pre-recorded here on my computer. And so I just want to show you this. So this is the start of the first one here. So first I just want to point out some of the equipment that we're going to be using. So this is a circuit board. If you remember from the videos from last week, I talked about this circuit board. So the two red knobs here are connected together, the three blues are connected together, these two greens are connected together, and these three silver are connected together. And so you can use this circuit board to actually build circuits here. Normally what you do is you connect a power supply like this one using wires. You connect the positive end to this red and then the negative end to this silver button here, and then you can stick resistors or other circuit elements either here or here or here or here, and you can actually build simple circuits. And basically all the circuits that we're going to be constructing, you'll be able to build those, or you would be able to build those with this circuit board. I have here a power supply, so I believe I would have demonstrated the green power supplies in the videos from last week. That's a simpler power supply. It just basically has two terminals and a single knob to control the voltage. So what I'm going to do actually in this video, what I do is I show you how this power supply works. It actually is a little more complicated. It involves four knobs here. This video is not going to involve the meters at all, but there's the meter off to the side here, and I'm going to show you what that looks like, upcoming videos. And here's a couple of circuit elements that we're going to actually use. So let me actually run this video here. So I just need to move the mouse and do it. Okay, so here I am. So right now I'm going to construct the circuit. So I've got, it looks like a light bulb. We put tape over the light bulb to protect it. This is, I believe, the 330 ohm resistor. And then I'm going to take some wire. So I've got a red wire and a black wire. So I'm going to connect it to the power supply. So there's actually 3 terminals in this power supply. There's a red, a black, and also a ground here. Anyway, so I turn this thing on. You'll notice that I turned all the knobs down first. So here I am. I'm actually adjusting the voltage knobs. So there's 2 knobs here, which are the voltage knobs. And you'll notice that I'm not getting any output. So the voltmeter is reading 0, and there's absolutely nothing happening with the light bulb. So what I have to do instead is I have to adjust the current over here, and then I can increase the voltage, and then I finally actually get some something across the light bulb here. So basically, the way this power supply works, there's 4 knobs. On this side are the voltage knobs. Let's see, as soon as I get my hands out of the way. So actually, let's just continue with this video here. So I'm now going to take this circuit apart. I'm sort of showing you how to do that. Take the circuit elements away here. So what I want to do is I want to just look at this power supply a little bit here. So we've got the 4 knobs. Oops, we just went on to the next video. Let me go back to the first one. All right, so I just want to show you this power supply and explain this a little bit more. So we have the 4 knobs here. So these 2 control the voltage, and these 2 control the current. So there's actually a current limiter built into this power supply. And so what I was doing was, when I was fiddling with the voltage knobs initially, I had the current set to 0. And so what ends up happening is that I can increase the voltage, but because the current is set to 0, this power supply does not allow any current. And so as soon as the circuit attempts to draw current, the power supply actually stops that from happening. And that's indicated by the fact that there's a red light there. So let me just show this again. I think we can skip me building the circuit here. Okay, so anyway, here I am making sure all the knobs are back to 0 again. This is, by the way, this is good technique here. So right now, you can't really see the color here, but there's a light over here. It turns out it's a red light. That light indicates that right now it's current limited. So again, here I am adjusting the voltage knobs, and nothing is happening. There's no voltage coming out. And there's a coarse tune knob and a fine tune knob, and neither one of them appear to be doing anything. So I turn them back to 0. Okay, now you'll notice that the light goes from red to green. And so that indicates that I've now turned the current up, and now this thing is voltage limited. Okay, so green kind of means, okay, ready to go. So you turn the current all the way up. And then what you can do is now you can adjust the voltage here. I wish I had taken my hand out of the way here, but there's 2 knobs, so I can actually, if I adjust the coarse tune knob, I can make really large adjustments to the voltage. If I turn the fine tune knob, you can see that the adjustments are a lot smaller. Okay, so big changes and then little changes. Okay, anyway, so I just wanted to show you how the power supply works and how you can build simple circuits with this thing. So what I want to do now is we'll go on to the next video. Here we go. Whoops, I went too far. So this is the second video here. So this shows the meter now. So this is the meter. So this meter is actually new. We actually got these meters since I had recorded those previous videos. So the meter kind of works the same way. It's a handheld meter, battery powered. It kind of works sort of a cross between the different meters that I had showed you in the previous videos here that we used to use more of. But anyway, right now the meter is off, and you should always keep the meter off. You'll notice that there are different settings here, so I can turn this dial here to different settings. There's a voltmeter, there's resistance, and I believe there's a couple of other things that I can't really see right now. But then there's also 3 settings for the current. Then there's the 10 ampere setting for the current, which is for large currents, and then there's the milliampere setting, which is the setting we usually use. And then for really sensitive measurements, there's the microampere setting. There's also 4 places you can plug things into. So there's a COM here, which COM usually stands for common ground. A lot of meters have a COM on them. But anyway, there's usually some indicated negative port here. So you would plug the black wire into the COM. And then depending on what you plan on using the meter for, you would plug the red wire into one of these three other plugs here. So if you're planning on using a voltmeter or an ohm meter, you would plug into the V ohm here slot. If you're planning on using the ammeter, then you would plug either into the 10 amp for the large fuse or the milliamp microamp for the smaller fuses, for the smaller currents. So I'll have an opportunity to show you, at least with the milliampere plug, so when we do the examples with current. But for this video, I'm actually going to show you how to measure the resistance values. So the first thing you're supposed to do in this lab is you're actually supposed to measure the resistance of 3 resistors and the light bulb using this meter. So I'm going to show you how that works. So here I am. First of all, I'm plugging the wires in. So black wire goes there, red wire goes there since I'm going to use the ohm meter. I just took one of the resistors. So I turn this thing to read resistance. The 0L indicates that the value is too large to be measured. So okay, I plugged in the resistance. And if you read the color code here, you'll notice that this is actually a 10 kilo ohm resistor here. And you'll notice it's actually showing up as infinity right now. And the reason is because when you set this thing on ohm meter initially, it turns out that this meter only measures small resistances automatically. There's a certain setting where it makes a very sensitive measurement of small resistances, but this resistance is too large, and so right now it's reading infinity. So there's a button, this orange button, that we often end up pushing, and let's see, oh yeah, it took a little bit of time there, I paused it there, but anyway, eventually what happens is it now registers, and so now you can see that it's reading the resistance. It looks like it's about 10.21, and it's maybe hard to read on this, but you'll be able to see in the images that I give you, you'll actually be able to blow them up. But the units are actually on the meter here, and right now this thing would say kilo ohms. So the kilo ohm unit would be lit up, and you would have, this would be 10.21 kilo ohms. So reading these digital meters is usually pretty straightforward. Anyway, so I'm going to take a photograph of this from this video and actually give it to you. It looks like it adjusted a little bit. Sometimes it takes a while for these meters to register. All right, so I've pulled that resistor out. Now I'm going to put in the next resistor. So this is R2. And you can see it automatically changes the range setting here. So now it's 101.5, and it should just be ohms or 4 or something like that. Anyway, pull that out. And then we put in the third resistor. So again, I'm going to have you read these. So I've got still photographs of these. I'm going to have you read them. So this is the third resistor. There's the measurement. And then you'll notice that I have the light bulb over here. So that's going to be the last thing that I end up measuring. Notice that when the circuit is disconnected, the resistance is infinity. That should, by the way, make sense to you. Right? If you break the circuit, there's no current in the circuit, and so the resistance is infinity here. You'll notice, by the way, you should notice that that light bulb was not lit up. Voltmeters or ohm meters do use a small amount of current or a small voltage to read, try to read the resistance, but the voltage that ohm meters typically use are typically on the order of a volt or so. And that's not enough to light up that light bulb. So that's going to play a role later on in this lab here. Anyway, so now what I'm doing is I'm demonstrating the second part of this experiment, which is using the circuits. So now I have placed the 330 ohm resistor in a circuit. And so what I'm doing is I'm actually going to construct a circuit that contains this resistor. These lead to the power supply. This was a voltmeter. Let me see if I can just go back there again and show you how I set this up. Yeah, let me actually go back here. Oh, it looks like I didn't start from the beginning here. That's why. Let me stop this. Let's go back to the beginning here. Okay. Yeah, so this is the beginning. Okay, so I'm now going to construct the circuit. And then I'm going to take this one of the meters. I'm actually going to use 2 meters here. So this one I'm going to set to the voltmeter. So it's set to voltage. Okay. Now I have to push this button because it turns out there's 2 settings on voltmeter. Same thing with ammeter. There's AC mode and DC mode. And this thing actually starts on AC setting. So we need the DC voltage. All right. So I'm plugging in the voltmeter now into the circuit. And so there it is. With the connections here, there's the reading. Right now it reads 0 because I haven't turned the power supply on yet. Now I'm going to connect up the ammeter. So I'm going to take a second meter. It's a different meter. Move this over to the milliamp scale because that's about the type of current. Again, I have to set this to DC. So there's an indicator there that you can use to indicate that it's in fact DC. Now notice where I put the red wire, right? Not here, but over there. And the reason is because this is supposed to be an ammeter on the milliamp setting. So, right, we insert the meter so that the current will run through it. So this is the ammeter. Now this is the ammeter and voltmeter together. Now, because I left this off to the side here, but there's nothing to measure yet. Now you can't really see it because the power supply is off to the side, but I'm right now turning on the power supply and I'm adjusting it. And in a moment, I'm going to show you the 2 meters. The results of that. Maybe we can speed this up a little bit. Okay, there they are. So right now, this thing is measuring both voltage and, come on. So right now it's measuring both voltage and current, right? So this is the ammeter, this is the voltmeter. Again, I'm going to have a still photo for you guys to read this. So this is reading the voltage across this resistor, and then this ammeter is going to read the current that's passing between here and here, which is the current that's passing through this whole circuit. So this is the voltage across the resistor. This is the current through the resistor, and it shouldn't be too hard to calculate the resistance of this resistor from these 2 values here. Okay, so anyway, there you go. Then what you're going to do, now I'm going to turn off the power supply. Again, you can't really see me do that, but you always turn the power supply off before you actually start mucking with the circuit here. So I pull the resistor out, put the light bulb in its place. I have to replace the ohm meter. Then I'm going to turn on the power supply. And you can see I'm adjusting it because you can see the light bulb now lights up. Okay, and now I am measuring, I'm going to pause it here. Now I am measuring the voltage and the current through the light bulb. And again, this is for a particular setting on the power supply here. And so we have a certain voltage value and a certain current value. So you should be able to read those 2 values and use those 2 values to calculate the resistance of the light bulb. The thing to keep in mind is this light bulb right now is right now lit up. So this is a different voltage than the ohm meter itself actually used. All right, so anyway, so I'm showing you, and I guess I keep showing you. And I guess that's probably it. So I turn the power supply off, and then that's the end of that video. All right, so that's as much as I wanted to say about this. Now I wanted to, there's a last part to this lab here that's going to require more data here. So this is actually a different meter. I believe I showed you this meter in last week's videos here. But this is an analog meter, so it involves a needle with a needle mechanism here. Basically, this needle deflects according to the current through the mechanism. And so you'll be able to determine it. It also can measure voltage, current, and resistance. We're actually going to use it as an ohm meter. So over here, there's a bunch of voltage settings. Over here, there's a bunch of current settings. And then over here, this is really bad in terms of accessibility because it's dark green on black, so you can't read the scale. But this is actually the ohm meter settings here. And so I'm just going to demonstrate how this thing works as an ohm meter. Again, there's a COM here where the black wire goes. And then there's a V and an omega, and also an A here. But this is for the small values, small fuse. So basically, the black wire usually goes here, and the red wire usually goes here. If you want to use either the high voltage setting or the high current setting, then you have to put the red knob over, or the red wire over here in order to, let's see, yeah, in order to get the higher fuse value here. But we're not going to be doing that here. I'm just going to be using this as an ohm meter, so I'm connecting to the meter. I'm going to use it to measure the resistance of the light bulb. Now, before I do that, so first of all, I have to set this thing to the appropriate setting here. So actually, I've just set it. You can't really read it here, but I've just set it to the R times 10 scale, which basically means that whatever the scale reading is, you multiply by 10 in order to get the number of ohms. Okay. Now, here's the thing. You'll notice that I actually plugged the red and black wires into each other. So right now, that meter should be reading 0. And you'll notice I'm pointing out that the needle actually is not reading 0. First of all, let me explain what scale we should be reading here. You'll notice there's a bunch of numbers here. There's a bunch of black numbers here. This is a proportional scale. This is for voltage and current. But if you remember how meters work, the way an ohm meter works is you actually, the ohm meter actually supplies a voltage, applies it to the resistor, and then there's a certain amount of current that's going to result from that. And this needle is going to deflect in proportion to the current. So actually the resistance scale here is a nonlinear scale because there's an inverse relationship between the amount of current that is generated and the actual resistance. So 0 resistance should actually result in maximum deflection, which is over here. We're actually going to be reading the green scale here. And right now it's not at 0. So there's a knob here, which is called ohms adjust, which you have to turn every time you use the ohm meter and you set it to a different setting here. You always have to do this calibration bit before you can actually measure the resistance of an actual circuit element. So now I've pulled out the light bulb. And so right now it's reading a resistance here. You can actually make it out on the green scale. It says 11. And since this is the R times 10 setting, this is 110 ohms. So right now this thing is reading 110 ohms. If you were astute, you may have noticed that that's a different reading for the resistance of the light bulb than we got from the other meter. And in fact, I'm going to be asking you why that happens. Another thing I should point out here, and this will be evident from the still photograph as well, there's actually a mirror here on this scale that allows you to place your head more accurately to avoid parallax. And you'll notice that the camera placement was not placed perfectly. And so you'll notice there's a slight offset. There's actually a reflection of the needle in the mirror and it's slightly offset. So there may be a little bit of parallax here. So it might actually be a little bit under 110 ohms. But anyway, it turns out this is the entirety of the measurements for this lab. It's a very simple lab. Usually what ends up actually happening, so that's the last video here. So usually what ends up happening in this lab is I usually spend the first week, I give about 2 hours of the lectures that you watched last week. And then that's about as much as anybody can take in one sitting, including myself. And then what I do is I give the last hour or so of that lecture. And then I give the brief introduction to the meters lab. As you can see, there really isn't a lot to the measurements here. That turns out to be the entirety of the measurements. But anyway, what I'm going to do in the next video is I'm going to actually go through the actual site. I'll actually show you what the, I'll actually show you what you're supposed to actually do for your lab and how you're supposed to work with the resources that I give you on Canvas. All right, so anyway, so in the next video I'm going to talk about what you're going to be actually doing this semester in this lab.